This video is on hydrocarbons. Hydrocarbons are compounds that contain just carbon and hydrogen. That's why they're called hydrocarbons. Now, there are three what they call homologous series of hydrocarbons. There are what are called the alkanes, the alkenes, the alkynes. And what these are is these are groups of compounds with very similar properties and who differ, members of which differ by a single number of carbons, and they differ by two hydrogens. So I'm going to first go over the example in the table, and then I'm going to do another example so we can compare and contrast here, okay? So here we go. So you have three structural forms here. You have a picture of something called ethane. Notice the suffix. You have a picture of ethene. Notice the suffix. You have a picture of ethyne. Notice the suffix. Each of these starts with the prefix F. F refers to 2. N in that case is 2, and that's the number of carbons, okay? So that's equal to the number of C's in those molecules. Now you'll notice each of those pictures has 2 carbons, but they have different molecular formulas, and there's something called a general formula over here. I want to see if you understand how this matches up. So I'm going to write out the molecular formula for each of these guys. So ethane, which only has single bonds in it, has a molecular formula of C2, that's N, H6. Ethene is C2H4, and ethyne is C2H2. Now look at the general formula column, right? So ethane has the formula C2H6, and it matches the general formula. Watch. If N is 2, then H is going to, the number H is going to be 2N plus 2. So what's 2 times 2? 4. What's 4 plus 2? 6. So ethane has the formula C2H6. Ethene has all alkenes have a general formula of CnH2n. So if it's an alkene, if the carbon is 2, the H is going to be 4, which is what ethene has. For alkynes, if the carbon is 2, the H's are 2n minus 2. So 2 times 2, which is 4 minus 2, and 4 minus 2 is 2. So, sorry. What if you had a bunch of 3 carbon molecules? Now, briefly, I'm going to show you something really fast here. Okay, this is the table of organic prefixes. If it's got 3 carbons, the prefix is going to be prop. We'll get back to this later. So we've got 3 molecules here. We have propane. This is called propane. This is going to be called propene. And this is going to be called propyne. Let's take a look at how these match up with the structural formula. Okay, so here we go. So this has C3. What's 3 times 2? 6. Plus 2 is 8. How many hydrogens do you see around this thing? 8. So this is the next member in the homologous series of alkanes. Something with 3 carbons has 2 more hydrogens. So all members of homologous series, the next member will have 1 more carbon and 2 more hydrogens. Okay. Propene, on the other hand, has 3 carbons, but it's going to have 2n hydrogens. So it's going to be just 2 times 3, which is 6. So if you'll see, there's 6 hydrogens. Propyne, right? Now I didn't put them all in here, but I want you to just take a look at this. The reason why it has less hydrogens on it is because the carbon can only make a total of 4 bonds. So if this carbon here and this carbon here and this carbon have already made, like this carbon here, this one I'm going to label carbon 2, already has 4 bonds around it. It can't have another hydrogen on there because it can only make 4. It has 8 electrons around it. The carbon that's on the left, number 1 carbon, has 6 electrons next to it, so it can have 1 more pair around it, so it can have 1 hydrogen there. So the form for propyne is going to be C3H2n minus 2. So 2 times 3 are 6 minus 2, which is H4. So those are the alkenes, the alkanes, and the alkynes. Now, one other term that's really important here. If there are only single bonds, it is said to be saturated. So alkanes are saturated, but alkenes and alkynes are not. Now, you've heard the word saturated before in reference to solutions. This basically means that there are as many hydrogens attached to the carbons as are possible. Saturated, like you've heard this term with fats, because like you've heard of like saturated, unsaturated fats probably. Saturated fats are things like butter, lard, shortening. They're solids. Saturated lipids tend to be solids. That's why they tend to be worse for your health, because they tend to block arteries and stuff. So they say you should try to avoid saturated fats. Things like olive oil are unsaturated. They have double bonds and triple bonds in the molecular structure, and they tend to have lower melting points and boiling points, so they tend to be liquids at room temperature. All you need to know is that saturated organic molecules have single bonds. Saturated single bonds. Remember that. All right, let's take a look at all these molecules. Now, you should be able to quickly use this table to figure out which of these guys is an alkane, or an alkyne, just by looking at the formula. So C5H10, does the H2N plus 2, 2N, or 2N minus 2? It's 2N. So this is going to be an alkene. And that means it's going to be unsaturated, because alkenes are unsaturated. C6H10, well, that's 2 times 6. So this is 2N minus 2, because 2 times 6 would be 12, minus 2 gives you 10. This is an alkyne, right? And that's also unsaturated. CH4, let's check it. Let's see. C2N, is it, okay, if it was 2N, you'd have 2 hydrogens, right? But you have 4, so that's 2N plus 2. This is an alkane. This is methane, right? Which we saw before. Okay, these 3 right here all have 7 carbons, right? Which one is the alkane? The one that's 2N plus 2. What's 2 times 7? 14. So this is the alkane. This one here is the alkene, and this one here is the alkyne. One last thing I want to show you is it doesn't matter whether something's branching or straight chain hydrocarbon. Like this first thing is a straight chain of carbons. If I put the hydrogens on here, this carbon here will have 3 hydrogens, 2 here, 2 here, and 1, 2, 3 here. Now I'm not drawing the hydrogens in, but I can count the dashes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. So this right here, this is C4H10. It's an alkane because there's only single bonds. It's saturated. This next one right here, okay, is what's called an isomer. It's got the same molecular formula but a different structure. It will have different properties. It's not the same substance, but the molecular formula will be the same. Why? Because you have put the hydrogen 1, 2, 3. This carbon in the middle, or the carbon 2, has 3 dashes around it. It can have 1 more hydrogen here. So if I'm putting the hydrogens in this, watch what happens. This carbon at the end can have 3 hydrogens. This carbon at the top here has 1 dash right here. It can have 1, 2, 3 hydrogens as well. If you count the hydrogens on this, it also is C4H10. So this is also an alkane. And notice, even though it's branched, it still has the exact same number of hydrogens, 10, 2N plus 2. Now, just briefly mentioning prefixes. If you're given a prefix and a suffix, you can figure out what the molecular formula for a hydrocarbon is. So octene has 8 carbons. Because of the suffix ene, I know its generalized formula is CnH2n because it's an ene. It's an alkene, which means I know it has 16 hydrogens. If I have octine, that also has 8 carbons, but it's got the YNE here, which means it's going to be 2N minus 2. What's 2 times 8? 16. What's minus 2? 14. This will be the molecular formula of octine. For pentane, pent, that prefix right here, means 5 carbons. So I write C5, and the H would be 2N plus 2, because this is an alkane. And 2 times 5 is 10, plus 2 is 12. So basically, alkenes and alkynes are unsaturated. You can use the general formula to figure out what their molecular formula is. Make sure you pay attention to the prefixes and the suffixes. Remember, they are unsaturated. Unsaturated compounds tend to be liquids. These are all high, and the members of the series differ by 1 carbon and 2 hydrogens. The alkanes are saturated. They only contain single bonds. And again, you can use the generalized formula to figure out what the molecular formula is because it's 2N plus 2.